Hi, Ann. This is your second podcast on these pesky polynomials. Let's just verify that we're good with what these things mean. So we started with something like this, all right? And I want to make sure you understand that this is just a number. So here's my polynomial, all right? They're all polynomials. This specific one is a monomial, and I also called it a term. And I know my kids get so confused because there's a lot of different words for the same thing. But monomial, it's also a polynomial. It's also a term. Any of those things is what they could call it. And I want to make sure you're clear that if I let this x equal, say, 5, that means negative 2 times 5 to the third power, and that 5 to the third power just means 5 times 5 times 5. So this, in this case, would be 125, so that's negative 250. So this scary looking thing right here is just a number. But it's not a number like you're used to until they tell you what x is. So we have to learn how to deal with polynomials written in this form with the variables. All right, I don't know whether this is going to help you or hurt you understand the idea of different terms. If I think of an x, let's do it this way. All right, if I think of an x as a length, so there is a length, and we're going to call this length x. It just has length. It doesn't have any area or any volume to it. And if I had 3 of those right up here, okay, I couldn't add them to an x squared. So if I took the same length for x, but I made a square where all the sides were x, I'd have an area now. And this area is not the same thing as this length. So I can't add lengths to areas. Likewise, if I took that same x and I made a cube with the same length, the same depth, and the same height, I'd have a volume. So the reason I can't add all these together is that they're fundamentally different things. And of course, you're going to have higher exponents than 3, but this gives you an idea of each exponent really means a different thing. So I can't put together things that have different size exponents. All right, first operation we're going to talk about is adding. And here I have 2 polynomials. This polynomial is a trinomial. It's got 3 terms, and I'm adding it to this polynomial, which has 2 terms. That's called a binomial. And all I'm going to do here is called CLT, combine like terms. So all that means is that I find terms like this one that have the same variable and the same exponent. So this is just 3x squares plus 4x squares together. That is 7x squares. So now these guys are out. And I like to cross them out. When I'm adding, I cross out stuff I've already combined. All right, the next thing I got is a positive 2x and a negative 7x. Well, when I put those together, I get negative 5x, because if I have 2 x's and I owe somebody 7 of them, that means I'm 5 short, negative 5x. And so I cross these 2 bad guys out. They're done. Now, the only guy I got left here is my negative 5, and he doesn't have any friends. He doesn't have any like terms, so I just write him out. So this is it. This is all adding polynomials is combining like terms. So all I have to do is find all the terms that have the same variable to the same exponent and add them together, just like I've been adding together, like I would add together money or anything else. Now, when I subtract, the only difference is if I have a subtraction sign outside of a polynomial, in this case, this binomial, I'm using the same 2, but I'm subtracting, I just have to change the signs of all the terms in here. You could think of it this way. This is like multiplying using the distributive property, each term by negative 1. The net effect is that it just changes the sign. So instead of positive 4x squared, I get negative 4x squared. And instead of negative 7x, I get positive 7x. The first term in this case does not change at all. And now I'm going to do the same thing I just did for adding. I'm going to combine the like terms. So if I take the 3x squared, but this time it's minus 4x squared, 3 minus 4 is minus 1x squared. And remember, I don't write the 1 if it's the coefficient. Then I got a 2x, and this time it's a positive 7x. So now I take those 2 and I get 9x. And negative 5 still doesn't have any friends and still can't play any reindeer games, so he just has to stay by himself. So that's adding and subtracting.